We previously found out that if the value of land initially is V naught, then after a certain period of time, let's say n years, the value of land grows to V. The rate R at which it grows is known as the growth rate of the land. So this growth was similar to how money used to grow. Now, do you think that the price or the value of every commodity on earth grows? Well, that is not the case. Consider a vehicle, let's say a two-wheeler, a scooter. Initially, its price was 40,000 rupees. Now, after 2 years, the price has decreased to a value of 32,400 rupees. Now, why does the value of the scooter not increase? This is because the scooter is being used by a person and it is undergoing wear and tear for 2 continuous years. So obviously, if the value initially was 40,000 rupees, then due to wear and tear, due to usage, after 2 years the value will not be the same and definitely it won't increase because the scooter has become old. So that is why the value decreases. So we find that it is not necessary for every commodity to increase in value after a certain period of time. The value can also decrease. And in this case, we say that the growth is negative. So in this case, we find that the growth is minus 10%. So this negative growth has a particular name to it. Let us find out what negative growth is called. Now, in order to calculate the final value, given that the initial value is V naught and the negative growth rate is R, then we will write growth rate as minus R because the value is decreasing. So if I rearrange this equation, then I will get V is equals V naught multiplied by 1 minus R by 100 to the power of n. This R is known as the depreciation rate, or the rate at which the value V naught depreciates in n years to V. So instead of negative growth, we call it depreciation. And using this formula, we can find out what the final or depreciated value of a commodity or entity will be given its initial value, the depreciation rate, and the time it is taking to depreciate. So now let us see how we can solve a very simple problem based on this concept. The problem states that the initial population of a town is 50,000 and it is decreasing at a constant rate of 8% because people are migrating from this town to other towns. And we have to find out what the final population of the town is after 2 years. So let's see how we go about this problem. We have to find out V given V0, which is 50,000 multiplied by 1 minus R, that is the depreciation rate given as 8%, to the power of n, which is given as 2. So this equation is going to yield the value of V. Now let me simplify this equation and write V is equal to 50,000 multiplied by 92 by 100 whole square. So on further simplification of this equation, I am going to get the value of V. So if I simplify this further by cancelling out the zeros in the denominator as well as the numerator, I obtain a value of V is equals to 42,320. So we found that the initial population V0 was 50,000, and due to migration and certain other reasons where the population decreased at a rate of 8%, the final population stands at 42,320 at the end of 2 years. So this is how we can apply the depreciation concept to solve problems of this type.